I've had several viewers ask me in comments, what would happen if you increase the capacitance on the 49-to-1 matching transformer? Will it help? Will it hurt? Well, we're going to find out today. I'm going to install 120 picofarad capacitors and 150 picofarad capacitors. Test them back to back, see what it does to the response curve. Watch to the end which capacitor is going to be the best with this 49-to-1 UnUn. Okay, we're back on the bench. We're going to be swapping out the capacitors. These were the original 100 picofarad TDK capacitors. We're going to swap those out. I've got some 120 picofarad TDKs and some 150 picofarad TDKs. We're going to replace the 100s with the 120s. We're going to go through our test to see what the insertion losses are and what our curve looks like across the bands. So stick with me till the end. We're going to go through all the tests. We're going to go through the summary and see which ones work the best. For this particular toroid, this is a 1002 toroid. I'll give you the full part number in the description. Also, all the parts that you see here will be available in the description so you can see the exact part numbers and where I source them. So let's get into it and start desoldering these original capacitors and put in the new 120s. Okay, I've taken the cover off of our 49-to-1 here. We're going to set it aside for right now. Going to try to desolder the original 100 picofarad capacitors here. I've got some hemostats on here. You can use needle nose, but these lock-ons was a little bit easier for me to work with, and try to desolder these connections here. Try to save the capacitors, but if we can't save them, that's okay. They're not that expensive. Get out the soldering gun here. Y'all know the story of this from my previous videos. Yeah, it's on. Taking a second to heat up. Get rid of this excess solder. Okay, now she's hot. And it don't take a lot to get it off of there now. Try to unwind where I wound it around that connection. Yeah, I believe I got it. All right, got one side loose. Let me disconnect from it. Try to get on the opposite side. You know, they serve two purposes. They hold the wire, the connector, but they also serve as a heat sink to prevent the capacitor itself from getting hot. So I'm going to try to, I can't see where the end of that is. Pardon me while I get my glasses. Okay, the end of it is up here, looks like. So I need to get in here behind it like that. And get her to heat up again. Okay, I should be able to, I slid it off though where it was soldered there, so it's loose. I should be able to unwind that conductor there. And it's still got a little bit of solder on it. Keep shaking it so it won't, no, it didn't work. That's still hot. It didn't take me long to look at that. You know the old horseshoe joke. It's been around for ages. We'll get this off of here now. Now we got it. That can be straightened out and reused, which we may have to do when we see which is the best of the three capacitors for this setup. All right. I'll go ahead and get out one of the 120s here. Get this up here where you can see it. But these are 120 picofarad right here. 120 picofarad, 3 kV ceramic disc capacitors. Also, I've been asked the question about mica capacitors. And what I have seen so far, the mica capacitors would work for low power applications. So those of you that are doing QRP or intend to stay below 100 watts and probably not running digital, they should work fine. But the voltage ratings on the mica capacitors that I have found, and I looked at a couple of different suppliers, only go up to 1 kV. And I question whether they could handle, you know, like 100 watts digital or not and survive. They may survive very well. And if any of you know of any that have been run at 100 watts or higher in this type of configuration, put it in the comments down below. I'd be interested in knowing and how they did that and what specific capacitors they were using and what their voltage ratings were. Okay, so we've got the 120s. It is, I can see it on here. It's almost impossible to read. I can tell it says 121J, 3 kV, and TDK. But these are 120s, and we'll connect them similar to what we had on the previous capacitors. Wrap them around once. That's the way I do it. You can do it however you prefer and what works for you. There's not a single right way to do it, but this is just the way that I do it. And we got it wrapped. And like I pointed out in some of my previous videos, electrical connections, especially similar to this, where you're connecting one component to another, it does better if you have both a solid mechanical connection. In other words, like I'm doing here, you know, that's hard to pull off as it is right now without it being soldered. But it doesn't have a good electrical connection yet. And that's what the solder will do. So we're halfway there. We've got a good mechanical connection, and I'm going to do the electrical connection now. Where's my roll of solder? Over here off camera. Okay, I got my solder. Let's heat up these joints. And that's good on that side. Turn it around here. And that should be good on that side. And we'll go ahead and trim some of the length off these. Doesn't need to be that long. It might have some interaction, so eliminate that as much as possible. I left the leads a little bit long. You know, if we determine which capacitor is the best, when we put it back on, we can trim these leads shorter. That way you have less reactance with the entire circuit there. That joint there looks like it might need a little reworking. I want to give these things a fair shot. I don't want to bias it if I can help it. Okay, that looks mucho better. Okay, so we've got the 120 on this one. Let's see if we can get this one off and save it. Maybe. We shall see. All right. Got a little something better to pull against here. Come on. Well, tell you what I'm going to do. For the sake of time, we're going to cut it. That can still be usable, I think, in some applications. Maybe not in this particular application, but on a circuit board, this one would still be usable. Got enough to stick through most circuit boards, get that little bit of insulation off of there. So anything that's usable, I don't throw away. I'm almost a pack rat, so I don't know. I have trouble throwing away anything that I might think I can use later. I try to reuse as much as possible. Of course, the thing with any of that is it where you can find it when you need it? And that's the story of my life. Okay, so let's get these leads bent a little bit. About the same. And I'll use these pliers where I don't have to clamp it. I can just hold it, I think, and get this down in here. Stick it down in there in between it, turn it, and then bend it over a little bit there, bend it over a little bit there. And get that up there. Now, hopefully you're able to see that. Got it wrapped around there. Let's get this one here soldered, and then we'll cut the extra length of the lead off and solder the other one. Go ahead and get this heated up. Oh yeah. Got that one soldered. Let's get in here, get that cut off, and try to get this one positioned and wrapped a little better. Okay. Now, there we go. All right. We got both our capacitors soldered in. We're about ready to connect everything and do our test with our nano VNA. So stand by, we'll be right back. Okay, we have our test configuration set up like we normally do. Got the nano VNA H4. We're going to be sending a signal out of port 1 into this toroid here, and these are the wound on the 264, 325, 1002 ferrite cores. This is a 14-2 tap configuration. You can see the tap right here for the positive connection, and the ground is right here connected to the negative on this breakout adapter for the BNC. We also have the ground running to the ground of this other transformer here, and the antenna is connected to the antenna of the transformer here. We've replaced both of our capacitors. These are both the 120 picofarad TDK capacitors. And we're going to run through our test just like we did for the other capacitors and toroids. So let's get the Nano VNA set up. And it's currently set up in SWR. So I need to change, leave it on that let's see, we already have it set up. There's log mag set up there, so we'll just turn that one off and we'll use the yellow trace for log mag. Here we are, we're set up in log mag and 1 to 30 megahertz. We've already gone through this setup, so I'm going to change to where you can see the screen better as we do our testing. Okay, we've got our Nano VNA H4 set up, and we're scanning from 1 megahertz to 30 megahertz, as you can see down here. And up here you can see our reading. This is going to be our insertion loss for both of the transformers, since they're hooked in back to back to each other. This is the back-to-back test configuration that we've done in our previous videos. We have to take this number here and then divide it by 2 to find out what the insertion loss for one of our transformers is. Okay, as we go through our test, I'm going to be writing them down here and then dividing by 2 here to see what our insertion losses are for the 120 picofarad capacitors. Now our first frequency is 3.827. That's what we've been measuring. We'll run up to that. There's 3.827, and that insertion loss there is 0.907. Let's go on up to 7.235, and there's 7.235, and that's negative 9.5, or excuse me, yeah, negative 950. Let's go up to 14.267. There's 14.267, and that's negative 1.82. Go up to 18.110. That's negative 908. Go up to 15 meters, 21,300. There's 21,300. That's negative 0.770. Wow, that's low. We may be in for a shock here on these new capacitors. All right, 24,925. There's 24,925. Negative 0.722 is what it's averaging there, looks like to me. Go up to 10 meters, 28,332. There's 28,332. Negative 0.85. That's what it's averaging there. From what I recall, these are extremely good. Let's see what the individual ones here are. That's negative 0.4535. And here we got negative 0.475. and here we're negative 0.91, negative 0.454, negative 0.385, and here we got a negative 361. Wow, these are good. I am shocked. And here we got a negative 0.425. All right, so that's the 120 picofarad test. These are the same UnUn matching transformers that we've been working on and testing. The only thing that's changed is the capacitors. This is the 120 picofarad capacitors. And if my memory serves me correctly, the insertion losses are less. We're going to compare all these once we get through with the 100 picofarad test, see what impact the 100 picofarad has on these. But as I recall, these are lower all the way across the band than they were for the 100 picofarad. So let's get those swapped out, then we'll run the test on the 150 picofarad. Okay, since we had just gone through the process of replacing the 100 picofarad capacitors with the 120s earlier, I didn't think it was necessary that we go through and video that process again. But now we have the 100 picofarad capacitors in both places, and we're going to set up and test and see what the results are here. Should be interesting. Okay, we're going to run through the test for the 150 picofarads capacitors. And just looking at the trace here, it's not quite as flat as it was for the 120s, but we're going to run through and check the frequencies and see. We're currently set up on 3.827, and it's reading 0.918, so negative 0.918 insertion loss. That's what we're measuring here. We'll go up to 7.235. There's 7.235, and it's negative 1.01. 1.01. And I can tell already this is higher than it was for the 120s. But let's go on 14.267. And here we are at 14.267. Once it stabilizes, it's negative 0.992. Go up to 17 meters, 18,110. There's 18,110. And we're negative 0.721. Go up to 15 meters, 21,300. And at 21,300, we're negative 0.61. Negative 0.610, we'll say. It's continuing to move there as we speak, but go up to 12 at 24.925. And at 24.925, we're negative 0.885. We'll go on up to 10 meters, 28,332. And at 28,332, we're negative 1.308 on the average. Okay. Let's get these divided out. This one comes up to 459, negative 0.459. Here we're negative 0.5 5, we're just going to round it off, 500. Negative 0.496. Here we're negative 3, 6. We're going to round that off to 0. That third decimal place is pretty insignificant, but not going to take it out to 4. Here we're negative 305. Here we're negative 4, 4, and we'll round it up to 3. And here negative 0.654. I think I did that right. Negative 0.654. If it's not right, it'll show up in the next screen. I'm going to put this into the spreadsheets, and we're going to do a comparison. We'll see where it goes. Stand by. Well, we've got our test results in, and just wanted to go back over. This is the original 100 picofarad capacitors, and remember, all of our insertion losses were between 10.1 and 10.9. We had 10.9 here on 17. We also had 10.9 here on 10. And that's flat across all the bands, and that is good. And then we substituted capacitors and put in some 120s. And here's the 120s. It goes from a low of 8% insertion loss to a high of 18.9% insertion loss. So it's got a much broader range, and that's not a good thing. It's not as flat across all the bands. Now, if you wanted to get the best capacitor, that's what these red dots indicate. The red dots indicate the lowest insertion loss on that particular band. So on 80, it had the lowest. Very little difference. And do you want to trade that to have an 18.9% insertion loss here? I don't think so. So let's look at the 150s. Then we'll compare all three. The 150 also had two low ones. And again, unless you're just wanting to work that band, is it worth the trade-off? So let's look at all three of them here. I think we can get them all on the screen. Get them lined up a little bit. Let's get it here. All right. So here's the 100, here's the 120, here's the 150. The 100 only had the lowest on the 40 and 20 meter band. But look at the differences here. The 120, it was 0.5% lower on the 80 meter band. It was 1% lower here on the 17 meter band. It was about 2.5% lower here on the 12 meter and 1.6% lower on the 10 meter. So that was promising. I thought we were going to have something there. But when you look here at what happened at 20 meters, wow, that's a killer for me. It may not be for you. You know, your situation may be different, but that's a killer for me. And then here on the 150 picofarad capacitors, we had two lows there. Here on 17 meters, it was 8% insertion loss, and there on 15 meters is 6.8% insertion loss. But it went as high as 14%. You know, these are pretty good until you get down to 10 meters. Now, if you never work 10 meters, this may be a good choice for you, because here it's 0.4% lower. Here it's 0.9% higher. Here it's 0.1% higher, but here it's 2.9% lower. And here, wow, that's 3.8% lower. Here it's 0.7, but here it's 3.1% higher insertion loss. So there's trade-offs. Is there any one capacitor that's best for all the bands? If there is one, I'm not aware of it. So just like with antennas, just like with transformers, these toroids, there are trade-offs and there are compromises. So what do you want? What's your goal? If you want the flattest across all the bands, it's definitely the 100 picofarad. You know, you've got a 0.8% variance from the lowest to the highest. 0.8%. You're flat pretty much across all bands. On these others, you're going to have outliers. You know, here on 20 meter band, here on the 10 meter band. So for me, and what I would prefer to know that regardless of which band I was on, I'm going to be having a really low insertion loss. And is it the lowest that you can get? No. But if you want to compromise, if you want to get so specific that you want the lowest, you're going to have 3 different combinations in order to get the lowest on the bands you're working. So here, you know, if you work 17 and 15 and you want the absolute lowest insertion loss, you'd have to go with the 150. If you want the lowest on 80, 12, and 10, you'd want to go with 120 picofarad. But if you want a flat response on all the bands, 100 picofarad is definitely the way you want to go. So that's the results that we got. This test was the response to comments I got from different viewers and wanted to test their theories. But I think for the best all around, we will stick with our original configuration, which was the 100 picofarad capacitors, the TDK capacitors. So hope you learned something from this. I did. I had not experimented with these others, but it was a good experiment. Hopefully we learned something from it. If you haven't already, be sure and subscribe. Click on the like button. Give it that thumbs up. It helps the channel. This is Kilo Mike 4, Zulu Kilo Bravo. Have a blessed day.